Yeah. So using the water, we just devise an instrument which will be capable of measuring the densities of the liquids directly. Generally, how we measure the densities of liquids is we take the mass of the substance, we take volume occupied by it, and then we take mass by volume ratio, isn't it?
Yeah.
But all the time it won't be an easy method, right? So what we do is we just design some instrument. If you dip that instrument in the liquid, it will directly give you the density, like how we are using thermometer. If thermometer is kept in our mouth, directly it will tell us the temperature of the body, right? So the
Yes,
same
ma'am.
way, hydrometer also, it's an instrument. This is designed for simplicity, and what it will be measuring, it will be measuring the densities of the liquids. So it is a device used for measuring the density of liquid directly. That means there is no need of mass calculation, volume calculation, or finding the density with comparison to water. No such requirements. Directly, if you dip this instrument in the liquid, it will give you the density. Okay. So generally, how we calculate is by comparison. Generally, what we do is in this instrument, Gautam, uh, when we dip it into liquid, no, let this be the hydrometer. So it will be having some bulb here, and there will be some calibrations here, like 1 centimeter, 2 centimeter, some calibrations will be there. So what you have to do, the actual procedure is we just dip into water first. First we have to dip it into water, and then second we have to dip into the liquid for which we want to find the density. For suppose I want to find the density of alcohol, then what I have to do, I have to take the alcohol and then I have to dip this instrument into the alcohol. So what they do is, by comparing with water, initially in the olden days they used to find the density. That is why the name was fixed as hydrometer. Okay. With comparison to water, they used to calculate. And how they used to calculate the density? For suppose density of alcohol is equals to, what is this tube actually? It's a long glass tube better, and at the down it will be having some lead balls will be there, and calibrations will be there. They used to dip this long tube in water first and later into the liquid for which we want to find the density. And what they used to note down is, when you dip this, what happens? Lead is a heavy metal, right? Lead is having more mass,
More.
so it will
Yes, ma'am.
sink into the water to some extent, right? Not completely settling down. Yesterday, I mean day before yesterday, I told you laws of flotation. So part of the tube will be inside and part of the tube will be outside according to its density. If density is very high, it will settle down, but if density is moderate, then what happens? Part of the tube will be inside and part of the tube will be outside. So when the tube is inside, what do? Is they just measure this length, how much tube length is inside the water. That will be taken as length of tube in water. Same thing, when they dip into alcohol, the tube, some part of it will be inside alcohol and some part will be outside. They just take the length which is inside the alcohol. Length of tube in alcohol. So this is how they used to find, Gautam. Like, means with comparison to water, they used to find the densities of the substance. But this is a very big process, right? So what
Yes, ma'am.
so what they did is, why to take a tube, why to take lead shots into it, why we have to measure the length? It's a huge process. So what they did is, they have done for length of the tube in water, length of the tube in alcohol, and seeing the readings, they have designed a simple instrument, that is your hydrometer. And now how it will work is, you just take any liquid. I'm just taking, let it be honey. Okay. Now when you dip the hydrometer, now hydrometer is ready. Then hydrometer is ready. Now when you dip into the liquid, what happens is, this hydrometer directly will give you the reading. How will you know the density? For suppose this is the surface of the honey, right? So at this point you have to see the marking. maybe it is 3 gram per centimeter cube or 4 gram per centimeter cube. That mark you have to see, what is the value of that mark. So this will be the density of the honey. Getting my point?
Yes, ma'am.
So what is the purpose of hydrometer? Directly we can measure the densities of the liquid. How can we measure? You just have to dip the hydrometer into a liquid and we have to see the mark. The surface of the liquid is coinciding with the mark on the hydrometer. But that mark is nothing but density. Okay.
Yes, ma'am.
And what is the principle for working of hydrometer? The hydrometer instrument works on the principle of law of flotation.
Law of rotation. Yes, ma'am.
What is this law of flotation? When you take the weight of the body that is immersed in the liquid, that will be equal to weight of the fluid displaced by the body.
Yeah, ma'am.
Okay, so this works on this principle. Any doubt?
No doubts, ma'am.
Okay. Now there are certain defects with this hydrometer. That means drawbacks. When you take very small changes in density, it won't be able to measure it. Okay, that means it is not used for minor measurements. Very small densities, it won't be capable of measuring. Okay, now when you take the liquid, two cases with very high density. Suppose you have taken a liquid, Gautam, which is having very high density, and you just kept the hydrometer into that. So when the liquid is having high density, can you tell me what will be the pressure of this liquid? Depth into density into gravity. Very high density means pressure exerted by that liquid is also high, right?
Yes,
Now
ma'am.
in this case what happens? Upthrust will be very high. So what happens to the hydrometer if you try to dip into it? No, it will float.
Ma'am, what is the maximum value of that hydrometer?
Maximum
Value, ma'am. Means till what extent will it show, ma'am?
range, I have not gone through it, but I think it was given in your textbook. It will be 15 centimeters long, in the sense it can measure the densities from 1 gram per centimeter cube to 15 gram per centimeter cube.
Ma'am, if the density of the substance is more than 15 centimeter.
That is what, no, if it is very high, it won't be able to.
Yeah, ma'am.
Okay, so in all the cases it is not suitable for measuring the density.
Yeah, ma'am.
Okay, so what happens when you take the liquid with very high density? In that case, if density is more, pressure is more, so upthrust will be high. Then what happens to hydrometer? Hydrometer will
Right.
not be in proper position, will not be in erect position. Completely vertical position is not possible. If it is perfectly vertical, it will partially immerse and we can see the marking.
Yes,
But
ma'am.
if the density is very high, if upthrust is very high, it is not at all in a proper position. It is floating and it will, shuffle its position. It will just dance on the fluid because fluid is exerting a lot of pressure on it. So it won't be in proper erect position and it won't give the correct reading. Okay.
Yes,
Now
yes, ma'am.
what if you take the liquid with very low density? What will be the problem? Let us take a liquid this time. Now this liquid is having very low density. What does it mean? Same pressure formula, depth into density into gravity. This time density is very low. So pressure also will be very low, right? That means what will be the upthrust provided by the liquid?
Upthrust is low.
Very low. So in that case, what happens to hydrometer?
It will
Beyond,
be
it will be sinking.
sinking. Okay.
Okay, because upward force acting, beyond force is negligible, very, very low. Then density of hydrometer will become large and it will completely sink down. So in this case, will it give you the complete reading?
No, ma'am.
No. So that is a problem with hydrometer. Okay, so that is why though we have the instrument, no, we don't use it completely because there are so many drawbacks for this instrument. But as just it was given in your textbook, I have explained you. Okay.
Okay, ma'am.
We use Archimedes principle, we use law of flotation principles to find the densities of liquids. This was just a proposal, but it has so many drawbacks. Okay, now
Yeah.
we'll take another instrument, that is lactometer. Lacto means related to milk. Okay, so this is also an instrument, this is also a device, and this is used for testing the purity of milk. Purity of milk. See, in this lactometer there will be certain markings, beta. There will be certain markings like m, m by 2, 3m by 4, and m by 4. Such kind of readings will be there. So when you dip into a bowl having the milk, you just have to see the surface of the liquid coinciding with which mark. For suppose I just take that the milk is coinciding with m by 4 mark, then what does it mean? The percentage of milk is m by 4, that means just 25%. M means concentration, the whole concentration is 100%, but in that the pure milk is only 25%, remaining 75% is water.
Means other impurities.
Yeah, impurities. Okay, for suppose if the mark is m by 2, half the m is nothing but concentration. M
50.
denotes, yeah, concentration. 1 by 2 of concentration means milk is only 50%. 3m by 4, 3 parts out of 4 parts, that means 75% is milk. M in the sense complete 100% milk.
Yeah.
Getting my point? So lactometer is a device which is used for testing the purity of milk. And how do we test the purity of milk? This is how we test it. Okay,
Yes, sir. Only 4 markings.
yeah, 4 markings. Like if it is in between also, Gautam, we can measure now. For suppose it is here, what does it mean? It is between 25% and 50%. So what is the midpoint of 25 and 50? Maybe 35.5, 37.5, like that. Markings will be there, but to make it simple we use 4 markings. If it is in between also, we just take the average of them.
Yes, ma'am.
Any doubt in this?
No doubt. No.
Okay, now we'll go for next concept, that is specific gravity. This is also called relative density. See, what is the main difference between density and relative density? When you take density, it is mass by volume.
Here it is total mass by total mass.
Not like that. Relative density means you are comparing the density of one substance with respect to density of another substance. Relative density means density of one substance with respect to density of another substance. What is that another substance generally we use? That is water.
Water.
Okay,
Okay.
but suppose I want to find the density of milk, relative density of milk, then what I have to do? Density of the milk in numerator, density of water in denominator. Getting my point?
Yes, ma'am.
Now when you take density of water, its value is 1 gram per centimeter cube. So can I simply say relative density is nothing but density of the substance only? Because
Yes.
density of water is equal to 1, so though you keep it in denominator or not, it will be same, no?
Yeah, ma'am.
Then what is the difference? If you see relative density, its units are gram per centimeter cube. When you take relative density, value is same, number is same, but here it doesn't have any units, because numerator density, denominator density, same units, they get cancelled.
Okay, ma'am.
Value will be same, density of a substance, relative density of a substance, but relative density there is no units, and density there will be units.
Yeah, ma'am.
Okay, clear with this? Now there
Yeah.
are certain formulas. Relative density of a substance is nothing but in terms of mass. If you take density, it is mass by volume. Density of water also mass by volume. When you are comparing two substances, no, you have to take the same volume. Density is mass by volume. No, volume will be considered same for numerator substance and denominator substance. Then density will be completely depending on what beta? It will be completely depending on mass, right?
Mass, yes,
So
ma'am.
you can write the formula like mass of the substance. M means mass, mass of the substance by mass of the water.
Why
Clear?
don't you take volume, ma'am? Once again, then.
See, when you are comparing two substances, no, we have to assume, if we assume that volume is same, that volume is same, because I told you, no, Gautam, I told you in which concept? Archimedes principle concept. For suppose you take the weight of the body in water, it will be equal to weight of the water displaced. Similarly, when you take the volume of the body which is immersed, it will be equal to volume of the fluid that is displaced.
Yes, ma'am.
Here we are talking about relative density of liquids,
Yes, ma'am.
not about solids. Okay, so if when you talk of the liquids, what do? We just take the body which is immersed into the liquid. So when you take body immersed in liquid, what happens? How much volume is the body inside the liquid? The same volume of the liquid will be displaced. So
Yeah, ma'am.
so volume will be same. So if volume is same, why we have to consider? We have to consider the changing parameter.
Yeah, ma'am.
The changing parameter is what? Mass. So even if you take here in the numerator mass by volume, denominator mass by volume, volume cancel, no?
Yeah,
Mass of the
ma'am.
substance is different, mass of the water is different. Why
Yeah,
volume is same here? Volume of the body which is immersed is equal to volume of the liquid that is displaced.
yeah.
That is why volume is same. So we take in terms of mass now. This is the original formula according to concept, and this is in terms of mass. Okay.
Okay, ma'am.
Okay. So there are certain formulas which are given, and there are some problems related to this formula. Derivations are not given, Gautam. Even derivations are not important for your objective as well. So I'm just writing the formula, important formula. You just memorize now itself. Okay.
Okay, ma'am.
What is density formula? Mass by volume. Unit, CGS unit, gram per ml, or you can take gram per centimeter cube. Second thing, if you take relative density, it is weight of the substance in air by weight of the substance in air minus weight of the substance in liquid. Memorize this formula. WA means weight in air. Sorry, we are comparing with water, no W. W is nothing but weight in water. That means what are we doing is, first we take the substance, we note its weight in air. Last class I told you, no, we have to attach the weight to spring balance. Outside it was 6 newtons. When you dip it in water, it was 4 newtons. Remaining 2 newtons disappeared. We
Yes,
have studied that, right? The same thing. You have to find the weight actually in air, then when you keep it in water. Okay, then what will be the relative density of the body? It is WA by WA minus WW. WA means weight in air, WW means weight in water.
ma'am. But weight in water is 1 gram. I said.
Weight of the water is what?
1 gram.
It's not 1 gram. Density of the water is 1 gram per ml.
Okay, ma'am.
Weight in water means what? How much weight was lost inside the body?
Yes, ma'am.
Apparent weight.
Yeah, ma'am.
Density of the water is 1 gram per ml. This
Yeah,
is
ma'am.
this is weight, no? You are measuring the weight. Weight is
Yes,
what? Weight is m into g.
yes, ma'am.
Okay. Similarly, you have to find relative density of some liquid. Then what is the formula? WA minus WL by WA minus WW. Extra term here, WL is nothing but what? Weight
Of that liquid.
in liquid. Weight of the body in liquid.
Yes,
How
ma'am.
much is the weight of the body in air? How much is the weight of the body in water? How much is the weight of the body in liquid?
Ma'am, that all values they will give in question, right?
We have to know. They will give you for problems. Experimentally, we will just take a spring balance. We'll take a beaker with different liquids, one with water, one with liquid. Then we just note down. First we'll dip into water, we'll note down W value. Then we'll dip into liquid, then we note down WL value. Then we just suspend it freely in air, then we note down WA value. That is how experimentally we do. But in problems they will give you all these values.
Yes, ma'am.
Okay, remember this, important. And
Okay, ma'am.
here we are considering CGS units, remember.
Yes, ma'am.
See, for suppose these are the formulas for relative density 2 and 3. For suppose they ask you density of the body, then what will you do? You have to
Mass.
take the same value but just keep the unit.
Ma'am, means mass by volume only, right?
Mass by volume, but mass volume are not given. They have given you these values, weights are given. Then what will you do? You
We
have
should
you
know
have
unit.
you have to use the formula according to the given data, right?
Yes, ma'am.
If mass volume is given, you will use first formula. If weights are given, you have to use, if it is for body, second formula. If it is for liquid, you have to use third formula.
Yes,
If
ma'am.
they ask you density, then what you have to do? Take the same formula, and what you have to do?
Second or
Extra,
third one?
yeah, second and third one. Take extra units. And which unit is this? Gram per centimeter cube. These formulas are applicable for CGS values of density.
Ma'am, no, ma'am. Which one for density? Which formula should you apply, ma'am? Second or third?
If they ask you find the density of the body, then you have to use second formula, keep the units. If they ask you find density of liquid, then take third formula, keep the units.
Okay, ma'am.
Okay, this is for density of the body. This is for relative density of the liquid.
Yeah, ma'am.
Clear?
Yeah, ma'am.
Memorize these formulas now itself. Relative density of body, WA by WA minus WW. Relative density of liquid, WA minus WL by WA minus WW. Remember this.
Yeah, ma'am.
Done?
Yeah, ma'am.
You have to tell me now. If they ask you even density, you have to use the same formula. But remember, density has units. Relative density has
Means,
no units.
if they give liquid, means we should use third formula.
Third formula. Third formula. Yes.
If they don't give liquid, second formula.
Yeah. We will do some problems today so that you'll understand. If you have memorized, let me know.
1 minute. Yeah, ma'am.
Done?
Yes, ma'am.
Okay. Now we'll see the next instrument, that is gas manometer. Barometer is used for measuring atmospheric pressure. Manometer is used for measuring liquid pressure. Gas manometer means this is a device used for measuring gas pressure.
Okay, ma'am.
Gas pressure. That's what, suppose in a container maybe oxygen gas is filled. You want to note down the pressure exerted by that oxygen gas. Then you have to use gas manometer. Okay. So how do we do this? This gas manometer will be having a U-shaped tube like this. Okay. It will be having 2 points. This is B point, this is A point. Okay. So first side we will connect it to the gas supply. That means you want to measure the pressure of which gas, oxygen gas or hydrogen gas. We will connect to that cylinder. Okay. And the other side, it is open to atmosphere. Okay. Now same tube, will just take 3 different cases. Point A, point B. Okay. So this is filled with some liquid. What is the use of this gas manometer is better? You can just decide whether gas pressure is more than atmospheric pressure or less than atmospheric pressure or equal to atmospheric pressure. You can justify that. Okay.
Okay, ma'am.
Now suppose you have connected to the gas supply now, and that is open to the atmosphere. See the case one. Okay. Now you don't see any ups and down in, just wait a minute, Gautam. You
Yeah,
don't
ma'am.
see any ups and downs in the levels of A and B. Between A and B we have filled some liquid, right? So
Yes, ma'am.
it was exactly at to the point A and to the point B. There is no up and down. So what does it mean? Left side pressure, right side pressure, both are equal. That's why liquid is not making any ups and downs. Left
Yeah,
side pressure on A side, pressure on B side, it is equal. That's why the liquid is stable. So in this case, what we have to understand is pressure exerted by the gas is equals to atmospheric pressure outside.
yeah, ma'am.
Okay. Now you take the second case. For suppose, imagine that gas pressure is more. Then what happens? On A side, more pressure is applied, right?
Yeah, ma'am.
Compared to B side. B side, atmosphere is exerting pressure, but left side, gas pressure is more. In that case, what happens? A side, more pressure will be there. So what happens to the liquid now? Pressure A side is exerting, I mean, the liquids on A side are experiencing more pressure. So they transfer this pressure according to Pascal's law on B side. Now what
Yeah,
happens to the level of liquid in B? It will rise.
it increases. Yes, ma'am.
It will rise. Now this will be the new B point. So if this is the case, if the liquid is more on B side and liquid is falling down on A side, then what does it mean? Pressure exerted by gas is more compared to pressure exerted by atmosphere.
And then A point also comes down, right?
Yeah, A point also comes down. This will be the new A point. Okay.
Yeah, ma'am.
Now how do you measure the pressure exerted by gas here? What do we do is we take pressure exerted by ATM plus there is a rise in B side, right? Let this be for height h. Now what we do is for this height h of the liquid we take its pressure, depth into density into gravity. We just take that height of the liquid, we take the density of the liquid, gravity. This is the formula for pressure due to liquids, right? HdG, depth into density into gravity.
Yes, ma'am.
Getting my point, Gautam?
Yeah, ma'am.
Pressure of the gas is more this time. How much it is more? Extra HdG part. It is more than atmospheric pressure. How much it is more? Pressure equal to HdG.
Yeah, ma'am.
Okay. Now let us assume that this is the gas supply side. Let us assume this side gas pressure is less. Now what happens? Right side B point will have more pressure from atmosphere. So at the A point side liquid level rises. This is new A point. And B side liquid drops
It,
down.
it
This is new
decreases.
B point. Now this time whose pressure is more? Atmospheric pressure. Outside pressure is more. So I can say now pressure of atmosphere is more this time compared to pressure of the gas. So
Yeah,
I
ma'am.
can say pressure of atmosphere is nothing but pressure of the gas
Plus HDG.
HdG. Which side HdG? This is the height of the liquid column, right? How
By
much?
A, ma'am. By A.
HdG. A side, how much level has been increased? You have to take that height and density of the liquid and G value.
Yeah, ma'am.
This is formula for PATM, but what we want to find the pressure of the gas. So what will I do? I'll send this HdG that side. So what will I get? Pressure of atmosphere minus HdG this time.
Yeah.
Any doubt in this?
No doubt, ma'am.
Okay. So equal levels at A and B points equal to atmospheric pressure. Unequal levels, then you have to see. If B side, atmospheric side pressure is more, then pressure of the gas is PATM plus HdG. Gas side, if level is more, then PATM minus HdG.
Ma'am, have you got that P gas is equal to PATM minus?
Here atmospheric pressure is more, right? Third case. Your doubt is in third case or second case?
No, ma'am, have you got that formula? Actually, ma'am? P gas is equal to PATM minus HD.
Okay. So imagine that uh, you have applied 2 newtons. We are just doing hand wrestling, okay? You have applied 2 newtons force, I have applied 2 newtons force. So do you think any one of our hand will fall down?
No, no.
No. Imagine that you have applied 2 newtons force, I have applied 5 newtons force. So whose hand will fall down now?
My hand.
Yours. So what is my force? No, my force is 5 newtons. You have applied only 2 newtons. Extra how much I have applied?
3 newtons.
3 newtons. So can I say that my force is nothing but your force plus extra 3 newtons?
Yeah, ma'am.
The same concept here. Here gas pressure is more
Okay,
than
ma'am.
ATM pressure. How much it is more? HDG times.
Yes, ma'am.
If this is more, right, if you take the pressure due to this height of the liquid, if you add that to atmospheric pressure, you will get the gas pressure.
Yeah, ma'am. Understood, ma'am.
Pressure of the gas is more, but how much times it is more? It's equal to pressure of the H part of the liquid.
Yes, ma'am.
Now third case, what is the thing? Atmospheric side pressure is more, so it will be pressure of the gas plus extra HDG.
Yeah, ma'am.
But we want for gas, so if you take for gas, PATM minus HDG.
Yes, ma'am.
You understood this point?
Yeah, ma'am.
Any doubt?
No doubt, ma'am.
If there is a small doubt also, let me know, Gautam.
No, no doubt, ma'am. Understood.
Okay. Now we'll go for Boyle's law. Actually, this is a concept related to your chemistry, but we'll just apply the same to the physics part here, okay? We will have extra one more formula. What is Boyle's law? If you take constant temperature and if you take constant mass of the gas,
Ma'am, Boyle is a scientist, ma'am.
yeah, it's the name of a scientist. Robert Boyle is the name of the scientist. He proposed this law.
Yeah,
Okay,
ma'am.
so it was proposed by the scientist Robert Boyle. Okay, so what does it say is, when you keep temperature constant and when you take the same mass of the gas, then what happens? Pressure of the gas is inversely proportional to volume of the gas. Pressure, P stands for pressure and V stands for what? Volume. So pressure exerted by the gas is inversely proportional to volume occupied by the gas. Why is it so? Because you just take a container, okay? Now this is the space you have provided for the gas molecules. Now they are very free to move, they have more space. So what happens? If you take within a small area, number of molecules is less. Now only very few molecules go and hit the walls of the container. That's why pressure will be less. For suppose if you decrease the volume, now what happens? All the molecules come closer.
Pressure will be more, ma'am.
Yeah, now if you take the same area, what happens? Within the same area, this time you have more molecules.
Yeah, ma'am.
So every molecule go and hits with the walls of the container, so pressure increases.
Yeah,
You
ma'am.
give less space, molecules are congested and so pressure will be more.
Yeah,
If you
ma'am.
give more space, what happens? In a selected space, number of molecules decreases. Here number of molecules less molecules
Yeah,
within an
ma'am.
area, okay? If you take the whole container, it will be same number, but if you take in a particular area, count will increase.
Yeah, ma'am.
Okay, so as volume increases, pressure decreases. So if you take proportionality removal, you will get some constant K by V. Now P into V is equals to constant. This is mathematical form of Boyle's law. You can also take it like P1 V1 is equals to P2 V2. Have you studied this in chemistry?
No, ma'am. Not yet.
Not studied. Okay. So you have studied in maths, right? Y is proportional to X. When you remove proportionality, you will get M into X.
Constant, yes,
Yeah,
ma'am.
the same way here, if you remove proportionality, you will get constant K. Now send V that side, you will get P into V is equals to K. That means the product of pressure and volume is always a constant. That is the meaning of this.
Yes, ma'am.
Volume increases, pressure decreases. Volume decreases, pressure increases. Ulta relation. But when you take the product of those two, always it will be a constant. So
Yeah, ma'am.
if I take for first condition P1 V1 constant. If I take for second condition P2 V2 constant. So what can I do? Whatever the values of pressure volume you take, their product is same. So I can equate this. P1 V1 is equals to P2 V2 is equals to P3 V3 is equals to how many conditions you want, that many.
Yes, ma'am.
Any doubt in this?
No, ma'am.
Okay. Now we'll do one thing. We'll take two different cases. So this is case 1. This is case 2. So case 1, this is the volume occupied by the gas. Here I have kept some weight. Let it be W1. Now what am I doing here? I'm increasing the weight here. W1, W2. More weight is kept. So what happens to the piston now? Piston will move down, right? When more pressure is there, it will go down.
Yeah, ma'am.
So this is the volume now. What about this? Piston has lowered. Piston is lowered. Why? Because of the more weight. Okay, now
Yeah,
this will be the volume occupied. So let this be V1 volume, let this be V2 volume. Okay. So what is the change from V1 to V2? V1 is more, V2 is less. So if
yeah, ma'am.
V2 is less, what happens to the pressure in second case? Let the pressure be P1 here, let the pressure be P2 here. So P2 will be more this time, right?
Yeah, ma'am.
So volume 2 is less compared to volume 1. If volume is less, pressure is inversely proportional. So P2 will be more compared to P1.
Yes, ma'am.
V2 decreases. That means P2 increases. Ulta relation. Volume less means pressure more. Clear?
Yeah, ma'am.
Now, if you see, if I take the total pressure, last class I told you, when you take the total pressure, we also have to include atmospheric pressure acting, right? If you see in both the cases, atmospheric pressure will be acting on the pistons apart from the weights, apart
Yes, ma'am.
from the outside weight, atmospheric pressure is also acting, no? So we have to consider that pressure also. So if I take total pressure in first case, it is pressure of the gas P1 plus atmospheric pressure. I'm just taking it as PATM. Second case also, if you take total pressure on the gas, it is pressure P2 plus atmospheric pressure PATM. Any doubt in this?
No doubt.
Okay. So what is the formula of pressure that we have studied? Force acting on an unit area, right?
Yes, ma'am.
Okay. So I can say P1 is nothing but force. How much force here? W1. Let me assume, see, if you take the whole container area is same. There is only difference in the height. If you see, this is the height of the gas in first case, H1. But this is the height of the gas occupied in second case, H2. But if you take the overall area of the container is same.
Yeah, ma'am.
Only there is a difference in height of the gases, volume of the gases. But area is remaining the same because you are using the same container.
Yeah, ma'am.
Okay. So what is P1 now? Force by area. So W1 by A. What is P2 here? Force by area. I'll just take W1 plus W2 extra one more W1. I'm just taking it as W2. Okay.
Yeah,
Why
ma'am.
W1 plus W2? Unnecessary confusion. Second case, force is W2. Area is same. So A. Any doubt?
Ma'am, one second.
Okay. First case, force acting is W1. Remove this. Second case, force acting is W2. Both the
Yeah,
cases, area is A, area is A. What is the formula for pressure force by area? So first case pressure is W1 by area, second case pressure is W2 by area.
yeah, yes, ma'am.
Okay. What is the formula of the volume? Can I take area into height? Length into breadth into height. That is a formula for volume. I can take length into breadth as the area.
Yeah, ma'am. So
What?
then area into height.
Volume is equals to area into height. Clear?
Yeah, ma'am.
Now, I'll do one thing. I'll just substitute here. P1 is W1 by A. Pressure of atmosphere, let it be P naught. P2 is W2 by A. Pressure of ATM is P naught. Is this clear? First
Yeah,
formula and second formula. Now,
yeah.
if you take volume V1, area into height is H1. If you take volume V2, area into, but this time height is H2. Any doubt?
No doubt, ma'am.
Okay. Remember this P total formula in first case, P total in second case. Okay. I'll just consider this for first condition. Volume 1, pressure in case 1. Volume 2, pressure in case 2. Now you apply the Boyle's law. What shall we get? Let us see. Pressure in first case was W1 by A plus atmospheric pressure P naught. Pressure in second case was W2 by A plus atmospheric pressure P naught. Volume in first case is area into H1. Volume in second case is area into H2, right? Now you apply the Boyle's law. What is mathematical form of Boyle's law for two different conditions? P1 V1 is equals to P2 V2. What is P1 here? W1 by A plus P naught into
Ma'am,
volume.
once again, can you tell me?
Okay. Are these formulas clear?
Yeah, ma'am. Formulas are clear. Yes, ma'am.
Okay. What is Boyle's law? Pressure is inversely proportional to volume.
Yeah, ma'am.
And I told you for two different cases. P1 V1 is equals to P2 V2. Product of pressure and volume will always be constant. If you take
Yeah,
P1 V1, constant. If you take P2 into V2, constant. So you constant. RHS is same. So you can equate LHS now.
yeah, ma'am.
Okay. What is P1 value? Pressure in first case. This is the pressure in first case.
Yeah, ma'am.
Substitute. What is V1? A into H1. Substitute.
Okay, ma'am.
Now right side P2. What is P2? This is the value of P2.
W by A,
W2 by A plus
P
P
naught.
naught. And what is volume in second case? It is
A,
A into H2. Anything gets cancelled? A gets cancelled. So what
yeah,
is
ma'am.
the final formula? W1 by A plus P naught into H1 is equals to W2 by A plus P naught into H2. Clear?
Yeah, ma'am.
Okay. Your chapter is completed. Any doubts in this chapter?
No, no doubts, ma'am.
Okay. Yesterday I sent you some pictures, right? Questions picture.
Yeah, ma'am.
How
Yesterday.
many questions? I mean last class.
1 minute, ma'am.
Mm. How many questions did we discuss in the last class? Let me know.
Ma'am, I think one pass, 1 minute, ma'am.
Mm.
We discussed the rectangular iron block is kept over a table. Ma'am, I think from 10th we should start.
Okay. So 1 second. I'll send you the picture of next page also.
Okay, ma'am.
Meanwhile, you go through that question and try to understand the question.
Yeah, ma'am.
Are you getting the concept at least to some extent, Gautam?
Yeah, ma'am. Yeah, ma'am.
You have to practice a lot better. Hmm? Because no, when I teach, no, it will be unclear, but when you read, no, it will be clear. When you practice, no, then you will get some concept into your mind. Okay.
Yeah, ma'am.
And when you read, it's not like I have told you that you have understood. When you are reading, maybe again you will not get. So that point what you have to do when you are reading, underline with the pencil wherever you are having doubt, or you mention in this paragraph I have a doubt, you can ask me in the next class. I have textbook with me now, so I can help you.
Yeah, ma'am.
Okay, so see the question number 10. We'll
Yeah,
discuss the. Mm,
1 Pascal in pressure generated by
okay, what is Pascal? Basically it is a unit of which quantity?
pressure, ma'am.
Pressure. What is the formula for pressure?
Pressure force by
Force by area. Okay, what was the question saying? Pascal value is 1, that means pressure is 1 Pascal. That is what they are saying. 1 Pascal means pressure value is 1. So when pressure will be 1? If numerator force is 1 Newton, denominator area is 1 meter square, then pressure also will be 1.
yeah.
If force acting is 1 Newton, area is 1 meter square, then 1 by 1, answer also will be 1 Pascal
Yeah, ma'am. Means 1 Newton acting per 1 meter square.
square. So what is the answer now? Option A.
Yes, ma'am.
Okay, now go
Ma'am,
through the
even C option can come right here.
1 meter square is equals to 1000 centimeter square. What is 1 meter? 1 meter is equals to 100 centimeters, right? I can write it as 10 square centimeter, right?
Yeah, ma'am.
Now what is 1 meter square? 10 square centimeter whole square. What is 10 square square? It is 10 power 4. Centimeter square is centimeter square. You must get 4 zeros, no?
Oh, yeah, ma'am. There 3 zeros. Yeah, ma'am.
Okay, now go through the 11th question.
Yes, ma'am. Two similar lorries. One is having 8 tires and other is having 4 tires having the same load. Which one will exert more pressure on Earth?
Hmm. See, two similar lorries. Okay, fine. One is having 8 similar lorries. That means everything is same except the number of tires. First lorry is having 8 tires. The second lorry is having 4 tires. Now, which lorry will have more contact with the earth?
8 tire lorry, ma'am.
8 tires. In this case, there is more area of contact. And what will be
So
the
pressure
pressure?
will be less, ma'am.
Very
Pressure
good. So, pressure will be less. Okay, now here
is
less
4 tires.
area with the contact. So, pressure will be more. What was the question asking?
Ma'am, they asked which lorry will exert more pressure.
More pressure. So which will exert more pressure now?
Lorry with 4 tires.
4 tires. So what is the answer now? Answer is option A.
Yeah, ma'am.
Okay, go through next question.
Yeah, ma'am. In which of the following cases the thrust on the surface is more?
The thrust on the surface is more. What is thrust? It is the perpendicular force, right?
Yeah, ma'am.
Now, horizontal surface. First case, same mass. Second case also same mass. Third case, same mass. I told you, thrust is nothing but perpendicular force acting on the surface. Acting on surface. If you take up thrust, it is force of the liquid acting on the body. This is just thrust. That means for solid objects. I told you, when you take a block of mass m, its weight mg will be acting on this surface. Now this mg is nothing but what? Thrust, the perpendicular force acting on the surface. Now here in the three cases, first case, second case, third case, the bodies are of equal mass. So there is no point of m here. Now if you see first case, additionally some F is also acting in downward direction. Second case, F is acting in upward direction. Third case, there is no force at all. What is the direction of thrust beta? This is the force exerted by body on the surface, right? This is
Yes.
the direction of thrust. So in this case, thrust direction is downward. Now if you see first case, already mg force, weight is acting downwards. Extra some external force is applied. Second case, mg force is downward, but this time F is applied in upward direction, so minus F.
Here
Third,
0. We can tell 0.
not 0, weight mg is acting, no,
Yes, ma'am. MG. Only
only
MG.
mg. So in which case thrust is more now, tell me?
MG plus F.
Mg plus F. That means answer is what? Option first
A.
body. First body is option A. Clear?
Yeah, ma'am. Yes, ma'am.
Thrust for solid objects is nothing but weight of the object. Third case, it is not zero. Weight is there, no?
Yeah, ma'am.
Now go through the 13th question.
Hydraulic machine work under the principle stated by.
Mm. So hydraulic missions work on the principle. What is hydraulic mission? I told you, pressing of the cotton bales, making holes in the sheets, getting the
Yes.
oil from oil seeds. One side we apply less pressure, the other side will get more force. The
Strong.
mechanical advantage. So this is all working on which principle?
Pascal's law.
Pascal's law. It works on Pascal's law. So answer is option A.
Yeah,
Now
ma'am.
go
Ma'am,
through.
if we keep a car on the other side and if we apply small force, the
Uh,
car.
yeah, that is also hydraulic press and works on the same principle.
Yeah, ma'am.
Mm.
In a Brahman,
In a
Brahma,
Brahma's press.
yeah, ma'am. In a Brahma's press, a force of 10 kg weight is applied on a piston of cross section 5 centimeter square. The upward thrust exerted by the piston of area of cross section 50 centimeter square.
Okay, that means there are two pistons now. This is first piston, this is second piston. On first piston, how much force is applied? 10 kilogram weight. See, they have not given newtons, they have given gravitational unit of force. 1 kilogram weight is equals to how many newtons? 9.8 newtons, remember. Okay, this is gravitational unit of force.
Ma'am, what is Brahman's press?
It's a mission name, beta. We are using mechanical advantage, no? That mission name is Brahma's press. Hydraulic press only, different names. And this
Okay.
is SI unit of force.
Yeah.
Relation between them. Okay. So this force, 10 kilogram weight force is applied, and what is the area of the cross section? It is 5 centimeter square. Now, so these two are connected, definitely will be by some liquid tube. So when you apply the pressure, what happens? According to Pascal's law, that pressure is transmitted to the second side. So second side, what will be the direction of pressure? It will be in upward direction. Here it is
Yeah.
moving in downward direction. Okay. Now, what is the area of cross section on the other side? It is 50 centimeter square. And they're asking you with how much force it is moving upward, up thrust. That
Yeah.
means this is effort, 10 kilogram weight. This is A1, 5 centimeter square. This is A2, 50 centimeter square. They're asking you load value. I told you in mechanical advantage, no? Load by effort is nothing but bigger area by smaller area.
A by A. Means R square by A.
If radius is given, here directly area is given, no?
Yeah, ma'am. Then
Okay.
550 by 5.
So
10.
what is load? We don't know. What is effort here? 10 kilogram weight. That is equals to A2 how much? 50 centimeter square. A1 is 5. So what happens here? 5 ones are 5 tens are
Ma'am, here A2 means the larger area.
larger area. Simple, Gautam. Load is which side? Right side. So if you take right side force in the numerator, you have to take right side area in the RHS side. Left
Yeah.
side force is E, so left side area in the denominator.
Yeah, ma'am.
Left side you are taking forces, right side you are taking area. So
Yeah,
load
ma'am.
that side, so area also that side. Load by effort, bigger area by smaller area. Okay,
Yeah, ma'am.
any doubt?
No, ma'am. Ma'am, then load is 100.
Load by 10 is equals to 10, and load is equals to what? 100. And what is the unit here? Load, first force is in kilogram weight, so here also force will be obtained in which unit? Kilogram weight.
Yes,
Here
ma'am.
centimeter square cancel. 10 kilogram weight as it is, so you'll get answer in 100 kilogram weight, but the options are given in newtons. So convert this 100 into 1 kilogram weight is how many newtons? 9.8 newtons. I can write it as 98 by 10 newtons. Now what gets cancelled? 10 10 cancel,
980 Newton.
980 newtons. So this is in which option? Option C. Clear?
Yeah, ma'am.
Any doubt? You have to remember the formulas. Load by effort is nothing but bigger area by smaller area. Which side is load? Bigger area side. Which side is effort? The one which we are applying force. Mechanical advantage.
Yes, ma'am.
Okay. Different names, load, upthrust, force, all mean the same.
Yeah, ma'am.
Now go through the
The
next question.
yes, ma'am. The buoyant in the buoyant force is equal to.
What is buoyant force actually? It is the upthrust of the liquid, right?
Ma'am, yes, ma'am. Weight of the liquid displaced.
So if you take first option, why not? Why can't the first option?
Weight of the body, ma'am.
So this is the body that is immersed in the liquid. Weight of the body mg will be acting downward. Buoyant force Fb will be acting upward from the center of gravity, center of buoyancy. So upthrust is nothing but what I told you, the weight of the body that is disappeared. I told you outside 6 newtons, inside 4 newtons. That means 2 newtons disappeared. That is the value of upthrust. Weight of
Yeah,
the body disappeared. This is also called apparent weight of the body.
yeah, ma'am.
Different things. This is also equal to what? Weight of the fluid displaced by the body.
Yeah, ma'am.
You have to connect every statement, and we have to choose which statement is given in question. Displaced by immersed part of the body. So buoyant force is equal to weight of the body? No. Weight of the liquid displaced by the body? Correct. So option B is correct.
Yeah, ma'am.
Difference of the weight of the body and the liquid displaced? No. The weight of the liquid displaced is nothing but the buoyant force. So again, there is no need of taking difference.
Yeah, ma'am.
Now go through today's images. Question number 16.
Yeah, ma'am. 1 minute. Yes, ma'am. A body is floating in a liquid. The weight of the body is.
A body is floating in a liquid, then weight of the body is. See, floating in the sense I told you, in law of rotation, two cases. Floating means maybe it
Buoyant force equal to.
it was like this, partially immersed, partially outside,
Yeah,
or
ma'am.
else maybe it is completely floating.
Yeah, ma'am. Means
Okay,
buoyant force is equal to weight.
yeah, if you see first option, then the weight of the body is equal to weight of the total liquid. No, only weight of the liquid that is displaced, not option A. Equal to weight of the liquid displaced by the body? Yes. So directly answer is what? Option B.
Yeah, ma'am.
Question 17.
A steel needle can be made to float on the water due to
Mm. So
Archimedes principle.
yeah, floating in the sense flotation. Flotation comes under was comes under Archimedes principle. It is floating. Why? Because buoyant force is acting on it. Needle is having very less weight. No, that's why it will completely float on water.
Yeah, ma'am.
Okay, so this is due to Archimedes principle. That is option B.
Yeah, ma'am.
Next question.
The weight of the body in air is 5 Newton and its weight in liquid is 3 Newton. The buoyant force acting on the body is
Okay, so weight of the body in air, that is WA, 5 newtons. Weight of the body in
W.
liquid. Liquid means WL, 3 newtons. The buoyant force acting on the body.
5 minus disappeared weight, ma'am. 2 Newton.
Yeah. So buoyant force is nothing but apparent weight, disappeared. So I can say WA minus WL. That is 2 newtons.
Ma'am,
Disappear.
in
Mm.
same question, ma'am, but if they ask to find the density of the body, ma'am, we should use a third formula, right, ma'am? WA minus WL by
No,
WL
no,
minus
no.
WL.
Data is insufficient because we need weight of the water, not weight of the liquid.
Yeah, ma'am. Okay,
Okay,
yes, ma'am.
data insufficient will be the answer in that case.
Okay, ma'am.
Okay, now go through the 19th question.
Yeah, 1 minute. Yeah. An object of density is 6 gram by centimeter cube.
Hmm.
Weight 18 gram in air. Its weight in water will be.
Weighs 18 grams in air. That means WA value. This is 18 grams. Its weight in water will be. So what will be its weight in water? An object of density. Its weight in water. Okay, so use this formula. This is density of the body, no? They are asking you weight in water, that is WW is question mark. So we
Yeah,
will
ma'am.
use the relative density formula. What is relative density formula?
WA
Weight
by
in A by weight in A minus weight in water, right?
W. Yes, ma'am. We can use.
Now they have given density, so we just take density now, but it will have units this time. I told you, no, relative density, density same formula, but
Yeah.
density we consider units. Formula is same.
Yeah, ma'am.
Okay, so density how much? 6. Weight in air 18. So 18 minus weight in water, let it be x. Now 18 into 6 how much? 6 is a 48, 108. Minus
108.
6x is equals to 18. Hmm?
Yeah, ma'am.
Now 6x send that side, it becomes positive. Bring 18 this side, it will become negative.
6x is equal to 108 by 18.
8 minus 8, 0. 100 minus 10, 90. So 90 is equals to 6x. Now x is equals to how much? 90 by 6. How much will be the answer? 6 ones are 6 1 6. 3 will be there. 6 5 are 30. So
15.
x is equals to 15. But what is this? This is weight of the water. So 15 grams.
Yeah, ma'am.
So how much is, where is the option? Option C.
C. Yeah, ma'am.
Okay. Now go through next question.
Yeah, ma'am. A nail weighs 15 gram in air and 12 gram in water. Then relative densities.
Question number 20, right? Okay. A nail weighs 15 grams in air. So WA value is given 15 and 12 grams in water. That means WW is given 12.
Yeah,
Then its
ma'am.
relative density. So what is relative density of the body? It's nothing but weight in air by weight in air minus weight in water. So this is 15 by 15 minus 12. So 15 by 3. So 3 5s are 15. 5.
Yeah, ma'am.
So answer, don't keep the units because this time question is relative density, so no units. So
Yeah, ma'am.
option B. Go
Yes.
through the next question.
Yes, ma'am. A body weighs 200 gram in air,
Mm,
180 gram in liquid, and 175 gram in water.
mm,
The density of the material of the body.
okay. So body weighs. So weight in air is 200 grams. Weight in liquid 180 grams. And weight in water 175. They're asking question for relative density or density?
Relative density. No, I'm sorry, density.
Density. So it will have units or not?
It will have.
It will have the units, okay? And they are asking density for the body. That means first formula. Density of the body is weight in air by weight in air minus weight in water.
Ma'am, then why did they give the liquid weight
Just
of
to
liquid?
confuse ante.
Ma'am,
Just to confuse you.
we can use third formula also.
Third formula is for what? Density of the liquid. No, they are asking for density of the material of the body.
Yes, ma'am. Yes, ma'am.
Getting my point, Gautam?
Yeah,
Second
ma'am.
formula for density of body. Third formula was for density of the liquid.
Liquid, yeah, ma'am.
They have given the data, but that doesn't mean that we have to use all the given data, right? What is required for us, that we will use.
Yeah, ma'am.
Now substitute here. This is 200. 200 minus 175. 200 by 25. 25 ones are 25 eights are. So how much are you getting density? It is 8, and what are the units? Gram per centimeter cube. But if you see the options, they are given in SI unit, right?
Yeah, ma'am.
So simplify now. 8 keep as it is. 1 gram is 10 to the power of minus 3 kgs, right?
Yeah, ma'am.
Divided by 1 centimeter is 10 power minus 2 meters, right?
Yeah, ma'am.
Centimeter cube. So cube 8 into 10 power minus 3 kg divided by 10 power minus 2 taken 3 times. How much will you get?
10 power minus 6.
Minus 6 meter cube, meter cube. So what gets cancelled here? Minus 3 cancel.
Minus
So you will
8.
have 8 by 10 power minus 3. Can I
800
write it as 8 into 10 power 3? Hmm?
Ma'am, 2 ma'am, not 3.
1 gram is 10 power minus 3 kg. 1 centimeter is minus 2. 2 3 is 6. How much will be left in the denominator? 3 only, no?
Ma'am, no ma'am, 3 ones are 3 twos are ma'am. 8 by 10 power minus 2.
What 3 ones are 3 twos are, Gautam? Will you cancel 3 ones 3 twos are like that? No. Numerator minus 10, 1 by 10s 3 are there. Denominator 6 are there. So 3 gets cancelled, 3 will be remaining. It's not like 3 ones are 3 twos are, Gautam.
Okay ma'am.
3 zeros in numerator, 3 zeros in denominator. Remaining 3 will be left in the denominator.
Okay ma'am.
What
Then
here is
8,000 kg per meter.
200, 200, 175. How much? 25. 400, 8. So 8 into 1 kg is 1000 grams. So minus 3. 1 meter is 100 centimeters. So minus 2. Mn formula 2 3 is a 6. Minus 3 minus 6. Maybe there is mistake in the answer, Gautam. 8000 kilogram per meter cube. Answer must be option A.
Yes ma'am.
Okay, option A is the answer. Okay, I just have kept the answers that was given in your back of the textbook, but here there is a small change. Answer is option A. Okay,
Yeah ma'am.
now so any doubt in today's class?
No doubt ma'am.
See the next question, 23rd one.
Yeah, one minute. 20. Yeah. When air is blown between the wall and calendar, suspended from peg on the wall, the
Mm,
calendar, then the calendar.
mm.
Ma'am, let me.
This is wall. To the hook, calendar is hanging. Now from here you have blown the air. That means air pressure is given. Wall is stable. Wall cannot move. So what happens to the calendar papers now? When you blow the air, air is
It moves
acting in this
forward.
direction. So it will blow away. If
It
you
moves away from the
yeah,
wall.
it will move away because you are blowing the air between wall and the calendar. So this is the paper, this is the wall, here you are blowing the air. So air pressure will be on the wall, on the paper in this direction.
Yeah, ma'am.
So paper will move away from the wall. Okay,
Yes, ma'am.
option A. Okay, what if you blow the air from the front of the calendar, it will move towards the wall.
Yeah, ma'am.
Okay, now go through next question.
Yeah, ma'am. Which of the following statements are correct?
mm,
Uh, Pressure is a scalar quantity. Yes, ma'am, it is scalar.
mm.
Uh, Pressure is equal to area by force. No, ma'am, it is force by.
Force by area. Complete the statement.
Yeah, ma'am. Next option. Yeah, ma'am. 1 bar is equal to 10 power 5 Newton meter square. Ma'am.
Newton per m power minus 2 means Newton per, that means divided by Newton per meter square. This is correct. 1 millibar is 10 power 2 Newton per meter square. This is also correct. If you see the past recordings, I have told you all these formulas. Okay, so
Yeah,
A
yeah.
is correct, option A correct, C correct, D correct. Now see the 24th one. Which of the following are the units of the thrust? Thrust is a force. So dyne is a CGS unit, Newton is the SI unit, kilogram per meter square. This is according to formula MA. Mass kilogram, acceleration meter per second square.
Yeah,
So
ma'am.
C is also correct. D wrong. So A, B, C are the correct options.
Yeah, ma'am.
Now choose the wrong statement among the following. The pressure at a point in a fluid. What is the pressure in a liquid? It is depth into density into gravity. Now see the statements. At a point in a fluid is directly proportional to depth of the point from the surface. Obviously, right, pressure depends on the depth. So this is
Yeah,
true statement. You have to pick the wrong statement here. The pressure at a point is independent of acceleration due to gravity. No, because you can see in the formula, it depends on the depth, it depends on the density, also it depends on the acceleration due to gravity. It depends, but he has given independent. So option B is wrong.
yeah, ma'am.
The pressure at a point is directly proportional to area of cross section. We don't consider area at all here. So C is also wrong.
Yeah, ma'am.
Pressure at a point is proportional to density of the liquid. Yes, it is proportional to density. This is a right statement, but you have to select only wrong statements in the question.
Yeah, ma'am.
So B and C is the answer.
Yeah, ma'am.
Now, the uses of hydraulic press are compressing the straw and cotton bales, correct. 26th one, option A, correct. Extracting oil from oil seeds, correct. Servicing the automobiles, correct. For measuring the pressure of a gas,
No, ma'am.
no. What do we use for measuring the pressure of a gas?
Gas manometer.
Gas manometer. Okay, clear, Gautam?
Yeah, ma'am.
So I did my best, Gautam. I just took only 9 classes, but I was not able to complete the whole syllabus. I covered only 2 chapters. Remaining, you have to read from your own. Okay,
Okay.
because we have started the classes very late, right?
Yeah, ma'am.
So I was not able to complete, but I think I have done my best. So you just do the revision. If you have any doubt, no, let me know. Okay.
Okay, ma'am.
Any doubt in today's class?
No, no doubt, ma'am.
Okay. So how was your mock test? Do you have that paper with you?
Yeah, ma'am. For in physics, no, ma'am. Total 342 marks, ma'am. I got 213.
Okay. So if you have the paper with you, will you send me?
Yeah, ma'am.
Later, not now. You prepare for the exam tomorrow after complete your exam, and then you can send me. Okay.
Okay, ma'am.
Okay. So I just took 10 minutes extra. Please don't mind, just for your exam sake. Okay.
No, no, no problem.
Bye, beta.
Bye, ma'am. Thank you.